Hey guys, Woodini here and welcome to part 2 of our Ultimate Streaming PC build guide. So we've already gone through all the components in the first video, we've unboxed them and we've seen them all. So in case you missed that, please go and check that out. I'll leave a link in the description below. So in this video, I'm going to be taking out all the hardware and I'm going to be putting them into the singular build. We'll start off with obviously an empty case, but hopefully by the end of this video, we're going to have a fully functioning PC.
First thing I'm going to do is install the CPU. The reason that you want to do that is because on top of the CPU, a lot of people misunderstand CPUs. That's actually a heatsink in and of itself. So you want to apply that A, so that we don't bend pins, B, so that nothing actually falls in, because we want as clean a connection as we can with the CPU onto the motherboard. There's a little lever, you just undo that lever, and again, super gently. Never force this, it just flows or slots in. The Ryzen will be sideways. It looks weird, but that's how it goes. It is in now, and all you do is your CPU is in. Point to note is you want to avoid as much static as humanly possible. So you might ask, it's a bit weird. So if you have an anti-static mat, great. Use the anti-static mat so that you're not building up static. Always make sure that it sounds, a bit overkill, but if there's something metal that's grounded, i.e. this cage behind me, you can just touch it to make sure that you remove static, so long as it's grounded. Okay, so because we are using a 360 millimeter all-in-one cooler, that you want to mount to the top, because that's where most of the heat is going to be generated, is from your CPU. Now that I've removed the fans from the top because of the AIO, I'm going to be remounting them to the front, and I'm actually going to be having those as intake. So just a small little tip, nothing major, but what you want to do to avoid as much cables floating around in the actual machine that you can see the visual aspect, you can just make sure that the top left corner actually goes in, and you can feed that, if I can find it, you can feed that ever so slowly into there before you mount it. So what you want to do is just tuck in the cables here, because we for the next few parts we're going to lie this flat, just safety sake, so that you don't bend, hurt any cables. We're going to start looking at getting the motherboard in. Reason being is, if you install the AIO before the motherboard, sometimes you are going to struggle to get cables through, which is why the AIO is actually going to be one of the last things that we put in. As you can see, the risers have to be installed, because obviously the case doesn't know which kind of motherboard you have. So what the best thing to do, which I did in the background to save time, is you just put the motherboard down softly, and you just align these risers so that the I/O ports are not obviously sitting off and the motherboard is not pressed to the metal. So these have been done and they are aligned already. So obviously make sure, if you need, some cases you don't need to use risers. This case does require risers. You would align all the pins. Just make sure that they all align, that one is not skew. Otherwise you might have just aligned a screw a little bit incorrectly, or a riser rather. So it's much safer just to redo it, because if you're ever deconstructing and you have a misaligned pin, it's a lot harder to take out. This is something you want to do extremely slowly, so that you only have to do it once. We want to quickly mount the SSD. This is the frozen heat shield, which is why I explained earlier that we're not going to need the one that actually came standard with the SSD. There's only really one important thing to do here, is that when you remove this, underneath there will be a little bit of plastic. I've done it, I think everyone might have done it, but this one's actually got a tab, so you can't miss it. Just remove that. All you do is, it's simple, it takes one, you just gently slot it in, it'll click like that, and you can see right there it just mounts up, and we just aim that screw in there. Now you got your mounted SSD. Best way forward is to always make sure that you have your cables, the cables that you're going to need. So immediately for the control panels for the fans, there's two. There's one for the AIO, and there's also going to be one for the case in its the case itself. So it needs a SATA power and a Molex power. So what I'm going to do is just get all the cables ready so I can feed them into their correct places, and you'll see why I did that just now. Well, I just eliminated a cable because that is from PSU into a Molex, and then this Molex splits, so I've got an extra Molex, and that connector goes into SATA, so now I can power the Aeolus, which is the Gamdias control center, as well as the case. First, one of the first points to call is you want to get every single cable that you have, even though this looks like spaghetti, you want to get it all to a singular point so that you're able to feed it. But how you have to feed it is you need to see every motherboard's different with regards to the inputs. Okay, you can see there's a USB-C, obviously. There's no USB input, so not going to need to use that, so no focal point. Your SATA drives and so on and so forth. But your motherboard's pretty standard, which will be your power from your PSU to power your motherboard, and then your power for your actual CPU. The cables, it's kind of like Lego, so you can't really get it wrong. So it's nothing you should stress about, but the reason I say it's to get your cables through is because once they're there, you can plug them in, you can always feed them back. See, I'm not doing this in any particular order, so what you want to do is feed that one underneath there. We can plug it in now. These ones are always a little bit irritating because the cords are very thick, so try put it to the side and then it just clicks. Do not pull on this cable because it'll bend the pins and then your frontal USBs will not work. Now let's just feed the rest of the cables through and then we'll do the rest. If you see there, sorry, this is for your audio. There's an actual, it blocks. So they purposely, how they work is they purposely block that port so that you can't put it into something else. So what you do is you just look to marry those two pieces, and you'll see that that will feed if you turn it perfectly like it was going to go in there. But there it fits in like Lego. Now you got your audio. Now we're starting to look at nice neat cabling. Cool. You can actually see we've done all of the cable work. CPU is plugged in, the fans are going out, the RGBs are all in, well, VDG and then RGB at the bottom. Motherboard's done, and all the front pin connectors are done. What you want to do is just feed these through before. You don't have to feed them all the way, just give it enough so that you can pull them on the other side. Just also make sure that the header is nowhere near the motherboard. Thermal paste. Now, please remember, it's not a cake. We're not icing a CPU. Thin layer. All it's there to do is to ensure that the plate of the CPU makes contact with this, and there's a medium in between to transfer the heat. There are various ways to do this. You can do, I'll show you my personal one, but you can do smearing, where you actually dot it and smear it. Remember, thin layer. Then there's the 5 dot, which I use. Then there's the 1 big dot. Last one is your X, where you actually literally write an X with the thermal paste. Again, it's not a cake, so you just want to put 1 dot there. That's even looking a bit too much. Don't want to use too much. That does look like a little bit too much, but it'll smear fine. We don't want it going over the borders of the actual CPU. So we will remove this. So what you do is, I've already pre-aligned this. You need to make sure that you align this before you put the CPU on. So what we're doing is we're applying equal tension or equal pressure to each side. So that's why we go until we feel a little bit of resistance on each side, and that's going to cause the thermal paste to spread nice and evenly. Now, again, you don't want to over tighten this, but you obviously definitely do not want to leave any room or gap. we're going to be installing the RAM now. So what's very important is to obviously marry the little tooth to the correct slot. You'll see that the correct slot is sitting more back, so therefore it'll be there to the left. Very simply, how these are fixed, so you can only open these. You can just open all four because you actually are installing four slots of RAM. And what we'll do, nice and gently, you'll make sure that you fit that piece in there, goes in, and then just gentle click, and you'll hear the click and the click. Your RAM is installed. We're just quickly getting ready to install the graphics card. I like leaving that for last before we clean up our cables. On the graphics card itself, it's reinforced, but you don't want any play on the graphics card itself. So we're going to be using, it actually came with the graphics card, a bracket that's going to hold it nicely in place. So what a really cool function of this motherboard is, it's got BIOS flash. So you don't have to go to your friend for a 3rd gen to upgrade the BIOS. You can literally just put it on a flash drive and then you'll slot it in. But moment of truth. Woo! Hey! We got that red light going. It just means that it's not posting. It's looking for everything, but there is no, the BIOS just doesn't recognize anything at the moment. So what I'm going to do is I'm going to turn it off and then I'm going to update the BIOS. There's a little square around here. I know it says HDMI, but that's actually that, believe it or not. There's a little square around there. That's specifically made for the BIOS. So you take the BIOS and you plug it in there. Now there's a little button over there. What you do, and there should be a light, and I'm praying that there is a light. There should be a light flashing now. Yeah, if you see right there back in the corner, there's a light flashing. And just now it's holding. That light's going to continue to go until the BIOS is updated. Do not remove power when you are doing this because it's pretty much GG for your computer. We've spoken about the motherboard, we've spoken about the graphics card. Let's speak about all the other components. And remember, we're talking from a point where we're trying to build something that is capable of doing gaming as well as streaming at the same time. And for that, we're going to look at the RAM itself. So as I mentioned earlier, it's CL19 RAM, but it kicks out 4,000 megahertz. Now, what that means in simple terms is that it is able to process information faster. Now, a lot of your programs, games, everything works off of how quickly your RAM works. And it's a well-known fact, especially with Ryzen, it likes fast RAM. So this RAM is definitely going to complement the processor. So we can actually move straight on to the processor for that part, where the processor is obviously the Ryzen 5. The RAM is obviously complemented by the CPU. So the AMD, the 5600X, it's 6 core 12 thread. So what that's going to allow is games that are especially heavy on a CPU resource, we can you would be able to use your graphics card for rendering. So there's an important thing to note when streaming, that you can't just have a good graphics card or a good processor. It has to be both. The reason for this is some games use both your graphics card and your CPU. So the usage varies on which game. Secondly, the type of encoding that you do depends. You can use what's called X264 encoding, or you can use NVENC or NVENC-NU. There's different types of encoding. And the different types of encoding would use the different components within your computer. The Antec 1000 watt titanium 80 plus or 80 rated titanium, this computer needs power, and it needs constant power in order to run effectively. So you need to make sure that you're supplying. We spoke about MOSFETs, we spoke about a lot VRM, which variable resource management or modules. But we need to make sure that the computer is being powered by something that is efficient. So a lot of people have bought 3070s or 3080s and the computer doesn't turn on, or they're not seeing any images because they haven't considered the power consumption that these components require. Talking about the radiator, we need to keep the CPU cool. Now, what's really great about a all-in-one cooler is if you're using call it a traditional or generic cooler, you're actually spitting that hot air back into the case, whereas this is feeding all that hot air out. So you're already eliminating one heat source, which allows everything to operate coolly. We then move on to the case, and we've configured that the fans in front are actually pushing air through. The fans on top here are sucking or exhausting the air, and the fans at the back, well, there's actually front mount fans as well, but we've created air pressure so that all of the air is being recycled within inside the desktop itself. On the CPU, also, there's a program or feature that you can download called Ryzen Master, which allows you to tweak your RAM and your CPU, but it's a really, really good function to be able to monitor the resources of your computer in a very detailed way. Resource management in streaming and recording is extremely important. You need to make sure that you have enough resources allocated to that. The SSD, we now live in a generation where information needs to be processed faster. By plugging an NVMe directly into the motherboard means that we're able to get the information that we require faster, which means quicker game loading times, quicker video editing. And what this all means is that you're going to be able to provide a better quality stream, a better quality performance, or whatever you want to call it, to your audience. And that's what the most important thing is. And that's why the graphics card, the motherboard, the CPU, the RAM, everything comes together. And what it does is it allows you to produce a quality stream by all working together. There is not a single component here that you want to cheap out on, or you want to buy something less expensive. Rather wait and save so you can get all the proper equipment, because what you're going to do is you're going to effectively limit yourself. If your RAM cannot keep up with your GPU, you're losing GPU processing. If your CPU cannot keep up with your RAM, and vice versa. These things all work in harmony. So it's something to be wary of.
Guys, thank you so much again for watching, and again a big thanks to the sponsors of this video, including all the brands that help make it possible. If you missed anything in the first video, please go check out the first part of the series, and if there's any questions that I didn't answer or any questions that you may have, please reach out to me on my social media, which I will include below as well. Lastly, a huge thank you to the team at Nexus and Glitched. They are the guys that did all the production, they are the guys that did all the post-production and made sure that this video was edited. And well, in the form that you guys see today, they are the real heroes behind the scene. So thank you very much to them. Guys, I thank you for your time. Hopefully this was educational for you. Hopefully this gave you a little bit of insight, and I look forward to giving you guys more content in the future to come. Cheers.